This example comes out of Math 20, section 7.3, absolute value equations, and we're going to do question 6e, solving this one. Absolute value of x squared minus 2x minus 16 equals 8. So here we have it written up on the board. We're going to do two things: solve algebraically and then verify your solutions. As soon as you see an absolute value symbol and you're solving algebraically, what you want to think is case 1 and case 2. Right away, write down the equation, write down case 1, case 2. Case 1 is just saying, okay, if what was in that absolute value was positive, the absolute value would be doing nothing. So we'd be solving the equation as if the absolute value symbol wasn't even in it. The other case, and by the way, we'll continue solving that with our usual quadratic kind of stuff from chapter 4. The other case is if what's inside that absolute value had been negative, the absolute value symbol would have made us switch the sign. So we will solve that case separately. So case 1 takes this. When we have a quadratic, we want to make it equal to 0. So that'll be my first step, make it equal to 0. Then we'd factor it if we can factor two numbers, think of two numbers, multiply negative 24 and add to negative 2. If not, we use quadratic formula. In this case, it factors quite nicely. And you end up with two answers: x equals 6, x equals negative 4. It's very important in these questions that you check these answers and see if they work. In this case, 6 appears to work if you stick it in the very original equation. Again, the equation you were given in the question, you have to check that and see if it works, but you do get 8 on both sides. And if you try negative 4, again, carefully with your minus signs, plus signs going where they belong, you get both of them working. When you do the negative case, you change the sign of everything on that quadratic side. So again, make it equal to 0. This case, I made it equal to 0 by moving it to the right side. Again, factored nicely, but if it hadn't, we'd just use quadratic formula. But we'll get two answers, two different answers in this case: 4, positive 4 this time, and negative 2. When I check these answers, verify them, check positive 4, it took me down, said, yeah, that works. Check negative 2, and we find out that that works. Another way to verify these would be to go back to the original and graph this as a function, the left side, graph the right side, and see where they intersect. And what you should find is that you'll have 1, 2, 3, 4 intersections. And so when they say verify graphically in their book, that's what they're looking for. There are questions where when you go to do this verify step, you get that none of the answers work. There are actually absolute value equations where there's no solution, even though you might have gotten 1, 2, 3, or 4 different solutions when you solved it algebraically. They all end up being extraneous. In this case, we have 4 good solutions with our cases. So hopefully that makes sense. I'll pan out so you can see it all at once and pause it if you need it.